Assalamualaikum and hi to all of my panel, Prof. Raja, Dr. Amran, Dr. Syukur. Today I would like to present Bachelor Degree Project 2 or PSM II. Okay, before that, I would like to introduce myself. My name is Muhammad Radin Najahan bin Samran. I'm the supervisor, Dr. Muhammad Sanusi, and my project title is Comparative Study on the Effectiveness of Minimum Quantity Lubrication, as known as MQL, between milling and turning processes. Move to next slide. This slide is about background of MQL. What is MQL? MQL is one type of cooling method that used in the CNC machining. MQL is the process of applying minute amount of high quality lubricant, vegetable based oil, directly to the cutting between tool and workpiece interface instead using traditional flat coolant. So next, MQL system. MQL system used for CNC machining process such as milling, turning, drilling, and suitable to cut high hardness material and workpiece. So we move to next slide. What function of MQL? First, MQL is cooling method that can remove heat rapidly. It can reduce friction and tool wear. It helps chips not to be welded on the tool due to heat generated during machining. And the last point is MQL helps to protect tool and workpiece from oxidization and corrosion. Why MQL is having most effective cooling system on CNC? MQL helps maximizing efficiency. Second, cooling method can producing the highest quality finished product. MQL also help increase machine to lifetime, and most important. Okay, so we proceed to next slide. This slide is about problem statement. So the first one is conventional coolant failure to clear weighted material and other debris. Other than that, negative environmental impact which leads to safety and health issues of conventional coolant. The last one is it accounts for 16 to 20% of the total cost of manufacturing production industry only for coolant and lubrication. Okay, this is study investigate which is the most suitable process between milling and turning using AISI 1045 under MQL cooling method. However, great effort have been made by many researchers to compare dry cutting and wet cutting with MQL. Many have studied surface roughness, tool wear, cutting force and cutting temperature on different machining process, including turning, milling, drilling, but there is still few research that compare percentage efficiency of MQL between milling and turning process. Therefore, this study is aimed to compare which processes is more suitable for MQL. So the next slide is about objective and scope of this study. So the objective is to investigate cooling efficiency of MQL in milling and turning processes environment using AISI 1045 compared to dry machining, and the second objective is to compare the cooling efficiency of MQL between milling and turning processes. So next is project scope. This project scope is focusing on comparing efficiency on MQL between milling and turning. Which process can come out better efficiency of MQL performance? This study is conducted by performing critical review and analysis from previous PSM report. Mike Wallace bin Muhammad Arzumi 2019, cutting performance in milling AISI 1045 under MQL lubrication system. Muhammad Rizwan bin Samir 2019, cutting performance in turning AISI 1045 under MQL system. So the cooling efficiency is measured based on percentage reduction of surface roughness, tool wear, cutting force and temperature between dry machining and MQL system. Next slide is about literature review. Yan Bin Zhang et al. 2018 in his research MQL in milling process, he found that experimented on milling operation and proposed that MQL based cooling method has improved the cutting performance. Other than that, Diego Caro 2015 in his research MQL system in turning, he found that MQL has been applied by many researchers to improve the outcome of turning process in several issues like surface quality, cutting temperature and tool life. Other than that, Tan Trong Handat et al. 2017 in his research effect of MQL on surface roughness, he found that MQL may be considered as economical and environmentally compatible lubrication technique. As Mausodi in his research effect on MQL on tool wear and cutting force, he found that MQL system strongly reduced the roughness over the dry and continuous fluid machining. For the cutting force, MQL decreased cutting force because consumption of lubrication of MQL method 7-fold less with continuous lubrication. This is also decreased the risk of disease of machine operator and the environment pollution. ZQ Liu et al. 2010, his research effect of MQL cutting temperature, he found that with an increasing quantity of MQL, the cutting temperature and cutting force are slowly decreased. Okay, we move to the next slide. This slide is about project flow with our objective and scope. So we start with literature review and continue to analyze and investigate previous data result, which is cutting performance in milling and cutting performance in turning under MQL system. After that, we need to be prepared the methodology. We study the technique and procedure for the past experiment, also the machining parameter. After that, we need to do efficiency comparison between dry cutting and MQL, which surface roughness, tool wear, cutting temperature, and cutting force. We analyze data and calculate the percentage comparison between milling and turning processes. So inside the methodology, this is the machining setup for milling experiment. As we can see, the cutting condition that used by past experiment, and this is our cutting parameter that used also in the past. So the next slide is about turning process. Okay, this is our machining setup. As we can see, this experiment also using AISI 1045, MQL nozzle, MQL hose, tool wear, and oil mist. So this is the cutting condition in the past experiment, and this is also the cutting parameter that we use in the past experiment. Okay, we proceed to the next slide. Next slide is about result and discussion about cooling effectiveness between dry cutting and MQL in the process between surface roughness and tool wear. First of all, this result is extracted and analyzed from the past student research, Muhammad Rizwan bin Samir, 2019. The title is Cutting Performance in Turning AISI 1045 and the MQL system. As you can see, this is the graph comparison cooling effectiveness between dry cutting and MQL in turning process. So first graph is surface roughness graph. First of all, the value of surface roughness in the past experiment for dry cutting is 4.21 micrometer, while MQL is 2.88 micrometer. As you can see, surface roughness under MQL method is reduced by 31.6% compared to dry cutting. This is because MQL has produced better penetration into cutting interface that causes reduction in friction and it produces better surface roughness. So next, the next one is the tool wear graph. The value of tool wear in the past experiment for dry cutting is 0.25 mm and 0.21 mm in the MQL system. The graph shows us tool wear improved by 16% in MQL method compared to dry cutting. This is because MQL provided the least accuracies of tool wear, indicating suitable of MQL in productive machining of AISI 1045 over the conventional dry machining condition. So we move to the next slide. The slide is still under cooling effectiveness between dry cutting and MQL in turning process, but between cutting force and temperature. First of all, this result is extracted and analyzed from the past research, and the author is Inkit Ardal ETR 2007. His research title is Effect of Minimum Quantity Lubrication on Tool Wear, Surface Roughness, and Dimensional Deviation in Turning AISI 4340 state. As we can see, the value of cutting force in dry cutting is 398.6 Newton, while under MQL is 302.4 Newton. So cutting force is decreased by 24.1% in MQL cooling method compared to dry cutting. This is because the contact between the tool and chip interface was smooth under MQL cooling method, resulting in lower cutting force for the machining process. Now we move to the cutting temperature graph. The temperature in dry cutting is 333.6 while 271.4 under MQL. So temperature reduced by 18.6 in MQL cooling method compared to dry cutting. The reason is MQL facilitates the process by removing the heat efficiently. The mist of synthetic ester produced from MQL penetrates the cutting. So next slide is about cooling effectiveness between dry cutting and MQL, but under milling process between surface roughness and tool wear. First of all, this result is extracted and analyzed from the past student research, Mike Wallace and Muhammad Rizwan 2019, cutting performance in milling AISI 1045 and the MQL system. These two graphs is about surface roughness and tool wear. So we continue to surface roughness graph first. From the past experiment, the value of surface roughness is 2.94 micrometer in dry cutting condition, while 1.43 micrometer under MQL condition. So surface roughness in milling process improved by 31.6% on MQL cooling method compared to dry cutting. The reason is, under MQL, the mist ejected penetrated the cutting zone, which is the contact surface between cutter and workpiece surface. So we move to the tool wear graph in milling process. From the past experiment, the value of tool wear is 0.08 mm under dry cutting, while 0.06 mm under MQL cooling method. Also, tool wear is reduced 14% under MQL cooling method compared to dry cutting. This is because MQL minimizes the tool wear by reducing the temperature at the cutting interface as the mist ejected penetrating the cutting zone. So the next slide is cooling effectiveness between dry cutting and MQL under milling process, but between cutting force and cutting temperature. First of all, this result is extracted and analyzed from past research, and author is Mahmoud Al-Bashar, ETL 2016. This research title is Investigation on Surface Milling of Hardened AISI 4140 Steel with Pulse Jet MQL Applicator. So as we can see, the left one is cutting force graph. The value from the past experiment under dry cutting is 274.5 Newton, while under MQL cooling method is 231.8 Newton. So the cutting force is reduced by 15.6 under MQL cooling method compared to dry cutting. This is because due to the low coefficient of friction and smaller particle size that penetrates into the cutting zone. So next we move to the cutting temperature graph. From the past experiment, the value of cutting temperature under dry cutting is 412.5 degrees Celsius, while 298.4 under MQL cooling method. So the cutting improved by 27.7% under MQL cooling method compared to dry cutting. The reason is MQL reduced the addition and friction between the tool and chip efficiently. The lower the friction, the lower the cutting temperature. So this slide is about comparison cooling effectiveness between tooling and milling. But before we compare both results, material removal rate MRR between milling and turning processes in both experiment result is about similar, so it considered comparable. As we can see, percentage of surface roughness and tool wear in milling is higher than turning process. There are several factors that cause it to happen. Pralhat B. Patel ETL in his research on MQL machining with nanofluid, he quoted that the first one is because penetration of MQL in milling between tool and workpiece is more efficient compared to turning process, resulting higher percentage reduction of surface roughness and tool wear. Besides, MQL can reach the tool face more easily in milling, resulting better surface finish compared to turning process. We can conclude that milling process is considered as better MQL effectiveness on surface roughness and tool wear compared to turning process. Okay, now we move to the percentage of cutting force. From the graph, we can see cutting force at milling process is reduced compared to turning process. ZKU ETL 2010 in his study cutting force and temperature of end milling titanium alloy with difference of MQL parameter, he quoted that smaller value parameter of cutting speed, feed rate and depth of cut resulting lower cutting force. This is the reason why percentage of cutting force is smaller in milling compared to turning process. So lastly is comparison between cutting temperature between turning and milling process. The graph shows that cutting temperature in milling is higher than turning process. Nihat Tosun ETL 2010 in his research about effect of MQL on surface roughness in milling, he quoted that at higher feed rate, more heat generated because of the higher metal removal rate, consequently increasing the temperature in milling process between the chip and tool interface compared to turning process. So the conclusion, we can conclude that MQL proved to be more efficient compared to dry machining in generating better quality parts with higher productivity and longer tool life. Other than that, MQL has improved surface roughness, tool wear, cutting force and cutting temperature drastically than dry cutting method on both processes. This is because MQL provides the benefits mainly by reducing the cutting temperature, which improves the chip-tool interaction and maintains sharpness of the cutting edge. Besides that, surface finish and dimensional accuracy improve mainly due to reduction of wear and damage at the tool tip by MQL cooling method. Besides, reduction in the tool wear would either lead to improvement in tool life or enhancement of productivity, allowing higher cutting speed and feel. And the last one is data percentage between milling and turning shows that milling has higher percentage of MQL performance on surface roughness, tool wear and cutting temperature. However, on the cutting force, data percentage shows that MQL efficiency. So finally, here is the recommendation of this study. So the recommendation is to perform machining experiment parameter with the similar MRR value to see the trend of MQL effectiveness. The second recommendation is to perform validation experiment since these results were from different reports. Okay, that's all from me for this presentation. I hope my presentation is clear. Thank you to all my panel and supervisor. Stay safe everyone.